Welcome to the last lesson that we have for this semester. We're going to be going over non-parametric tests, and in particular, our focus is going to be on the McNemar test. In order to figure out what a non-parametric test is, we first should probably review what a parametric test is. So, every test we've done so far has been some variation of using either a t-score or an f-score, and both of those come from distributions that have certain assumptions that we've always been checking, right? So we've been checking whether they have normality by using the skewness and kurtosis, and we've also been checking that they meet the homogeneity of variances as well. So tests that meet both of those assumptions, normality and homogeneity of variances, are generally referred to as parametric tests. So non-parametric tests are going to be when we do not meet the assumptions of normality and the homogeneity of variances. Let's just review a couple different examples of non-parametric tests. I'm going to start off with these ones here. All have a dependent variable that is on the nominal scale. Okay, so remember, nominal scale means name, not like numbers, which is how all of our other dependent variables have been. They've always been at either the interval or ratio level. And here we're at the nominal level. And all of these ones are based off of the chi-squared test for frequencies. And you can see there's 4 different ones I have listed here. For a one sample case, we use the chi-squared goodness of fit test. If you have a 2 sample case or an any number sample case, that's what the K stands for, is basically like any number that you want to scale this up to, we would use something called the chi-squared test of homogeneity. If we have a 2 sample cases with dependent samples, then we will use the McNemar. That's the one we're focusing on today. And if we were to have a 3 sample case with dependent samples, you would use something called the Stewart-Maxwell test. Continuing on, all of these ones are if the dependent variable is on the ordinal scale. So if you have a 2 sample case with independent samples, you could either use something called the median test or the Mann-Whitney U test. If you have more than 2 sample case, where you have 2 or more independent samples, there's something called a Kruskal-Wallis one-way analysis of variance, or one-way ANOVA, but a slightly different one than the one we did. And I have no idea if I'm pronouncing their names right, so apologies if they ever watch this. We also have a 2 sample case with dependent samples, which would be using the Wilcoxon matched pairs signed rank test. That is a mouthful. Our focus for today is going to be on the McNemar test. And the reason that we're focusing on this particular test is you're going to use it in the fall in ED 804, I think is the number. It's the class with Dr. Pirro. And you're going to be tasked with doing the scenario that we're going to go over later. So you can actually refer back to this video and refer back to these notes, and it's going to directly help you next semester when you're doing that. So let's just dive in a little bit deeper into what the McNemar is and what the basic definitions are. So its official name is the McNemar test for significance of change, and it is used for dependent samples involving frequencies. It's most often used in a pre-test, post-test design, where we have a sample of participants is categorized in something before and after some sort of treatment. And here's the key part of this. We have one dichotomous dependent variable on the nominal scale. So dichotomous means that there's just 2 options, and nominal, again, means name. So for us, our example is going to be using KC, or knowledge and comprehension questions, versus the HOTS questions, or higher order thinking skill questions. So those are going to be our 2 dependent variable levels, is either KC or HOTS. The independent variable has 2 related levels. So our related levels are going to be off of time with this before and after. And that's it. Let's just jump right into actually performing the data analysis using the McNemar test. We have all of the exact same steps that we've had all along. Nothing has changed here. And here is our official scenario. So this is what you will be doing in the fall for Dr. Pirro's class. You have gathered pre- and post-observation data about the numbers and types of HOTS questions and comments used in a select classroom. In between the observations, an instructional theory was chosen and an improvement plan to increase HOTS questions and comments was developed. And what we want to do is see whether there was a difference in the frequency of these HOTS questions and comments between the pre- and post-observation data. Here is the sample data that we're going to be using for our scenario. We have a before count with our number of KC questions and our number of HOTS questions. We also have an after with the number of HOTS and KC, as well as being able to see the breakdown of before versus after for each one of these. Now, before we actually do anything with this data, let's just get right into the write-up. So, step 1, data cleansing. As usual, the data has been cleansed for you already. You are welcome. Our research question is going to be, is there a statistically significant difference between observed frequencies of KC or HOTS questions and comments before and after an intervention to improve questioning in the classroom? It's a little bit wordy. You might want to focus on changing this a little bit in the future or for your dissertation, because it's not necessarily the best wording of this, but it's good enough for us and it will be good enough for you next semester. Step 3, we have the independent variable, which is going to be time with 2 levels, pretest and posttest at the nominal level. Now, you might consider relabeling this. Instead of being pretest and posttest, you might use the words before and after, which is what I did in my dissertation because I didn't like the words pretest and posttest. They didn't fit my particular scenario. And you might say before and after because you're talking about before giving an intervention and after getting that intervention. So those might be better words that you might consider using instead of pretest and posttest. Step 4, we have the dependent variable, which is represented by the frequency of KC and HOTS questions and comments, and this is at the nominal level. Our null hypothesis is going to be that there is no statistically significant difference between observed frequencies of KC and HOT questions and comments before and after an intervention. The alternative hypothesis is that there is a statistically significant difference between observed frequencies of KC or HOT questions before and after an intervention. As per usual, our alpha level is going to be at 0.05. For our type of statistical analysis, we are going to be using a McNemar test for significance of change in order to assess the differences between observed frequencies of KC or HOTS questions and comments before and after an intervention. There are 2 assumptions that we need in order to use the McNemar test. The first is that we have a dichotomous variable with 2 mutually exclusive groups, and the second is that we have an independent variable consisting of 2 categorical related groups. So for the first one, our dichotomous variable is our dependent variable, which consists of either KC or HOTS as our labeling. And these groups are mutually exclusive, which means no overlap, meaning that no question or comment was ever classified as both a KC and a HOT question. So they are always categorized as one or the other. Therefore, these groups are mutually exclusive, and this assumption is met. Our independent variable is time, and it has 2 related categorical levels of pretest and posttest. Therefore, this assumption is also met. Now, for computing the test statistic, we're going to go over 2 different ways of doing this. The first is going to use an Excel spreadsheet that I've created for you, and the second will be using SPSS. There are pros and cons to using either one. The Excel spreadsheet is very quick and very easy if you already have summary data, and the SPSS output one is, in SPSS, so it's never the easiest thing in the world to use. And in the comments for this particular slide, there's also a link to a third way that you can do it in SPSS, but I could not personally actually get that one to work. So I'm going to stick to these 2, And let's begin with the Excel one. So why don't you open up the McNemar test template file and we'll take a look at that. Okay, so here I have the McNemar test template that I've created for you. And before we actually input any of our data, let's just take a second to look through what is happening with this file. The first things we have up here at the top are going to be instructions for us. So we are going to have to relabel the yes, no to be our dichotomous dependent variable levels. So for us, that's going to end up becoming KC and HOTS. So let's just change those right now. So I'm going to change the no values to be KC, and I'm going to change the yes values to be HOTS. Once we've done that, we need to relabel the before and after to match our independent variable levels. So I've had everything worded as pretest, so I guess that is what I should continue to do here. And after, I should change this to post-test. If you'd like to leave these as before and after, you're more than welcome to. Next, it asks us to enter in the proper cells right here in red. So what I'm going to do is jump back to the slide way back in the beginning and pull in that data. So here is the data that I'm going to input into this Excel spreadsheet. So this first one, this needs to be 14. So that was the number of people who during the pretest or the before test had KC and after switched to HOTS. Next, below that, we're going to have 16, so that's the KCs and KCs. The HOTS and HOTS are 6, and this one is 2. And we can look here, this is 38, which matches this. These guys add to 38, which matches this. And you might have noticed that as I was typing, some things changed automatically for us down here. So the way that this template works is that it's actually comparing critical values rather than p-values. And that's just because it's a little trickier to find p-values inside of Excel than it is to just use critical values. So what I have here is the calculated McNemar critical value. Okay, so for this particular one, it is exactly 9. It's not always a whole number, that just happened to work out for us this time. And below it, what I've done is found the critical value for the type of situation that we're in. And this is what we're comparing the McNemar critical value to. Now, in order to make your life a little bit easier, since we're not used to dealing with critical values, I added in this extra formatting for you, which basically tells you whether you're rejecting or not. So if it's highlighted green, like it is in this case, we would reject the null hypothesis. If it was highlighted in red, it means that we fail to reject. So I'm going to show you that by just modifying this data set up here and changing this number to a 1. And you can see once this became a 1, this value now switched to red, and that would mean that we failed to reject because we did not pass this critical value threshold. And I'm just going to emphasize that you do not need to understand how this is working with the critical values. You just need to be able to interpret that green means reject and red means fail to reject. That's it. Now, in order for us to figure out what this actually means, this rejecting and fail to rejecting, what we're going to look at is the top left and the bottom right cells. That would be the ones where in the pretest we had KC and in the post-test we went to HOTS, as well as in the pretest starting with HOTS and switching to KC. So these are the ones that indicate a change in response from pretest to post-test, meaning we went from one level to the other when we switched from pretest to post-test. And this is what we want to try and compare here. So what we can see from this is that there were more people that switched from KC to HOTS than there were that switched from HOTS to KC. And since we have a rejection here, we can say that that actually happened with a significant value, that we know that a significant number of people switched from using KC to using HOTS questions after our intervention because more people switched from KC to HOTS than went from HOTS to KC. Next, let's take a look at how to do this in SPSS. So if you'd like to open up the example data set in SPSS, we can take a look at that and go over how to run the McNemar in SPSS. Here is the data in SPSS. You can see that we have words going on over here with low and high and low. I tried to use abbreviations and SPSS did not like that for some reason. So that's why I just have the KC questions labeled as low and the HOTS questions labeled as high. If we take a look over here, they're both nominal values, which we already knew, and I've just labeled them as before and after. And again, you could change that to pretest, post-test if you wanted to. In order to run the McNemar in SPSS, we can go to Analyze, Descriptive Statistics, and we're going to go to this one that says Crosstabs. And I'm just going to line up with how our table was, which our table had the before as the columns and the after as the rows. So I'm just following what our table was. In statistics, I'm going to go way down here and select McNemar. So once it calculates, you can see what it spits out for us. It gives us this nice summary table, which we already have in Excel, and then it gives us this chi-squared test down here. And the only advantage for us using this is that it gives us a p-value right here, 0.004. But notice that it did not give us the actual chi-squared value either. So neither one of these tests is perfect. If we use SPSS, it will give us a p-value, but it does not tell us the chi-squared value. If we use our Excel template, it gives us the critical value, so our chi-squared value, but it does not give us the p-value. So the way that we're going to do this is you're just going to pick whichever one you like better. Either use Excel or use SPSS. It does not matter to me which one you use. You could combine and use both if you'd like. So there you have it. There are our two main ways of computing this test statistic. We have our Excel output giving us the McNemar chi-squared of 9, which is highlighted in green, so we know that we're going to reject. Or we have the SPSS output with a p-value of 0.004, which is less than 0.05, so we're going to reject. Small p-value equals reject. And here we have our two different ways of writing it up. One if you have a p-value, and one if you don't. So I'm going to use the Excel write-up because that's the easier one for us. So here we go. There was a significant difference in the frequency of KC and HOTS questions and comments for before and after an intervention with a chi-squared degree freedom of 1 equal to 9, as compared to the critical value at an alpha level of 0.05, chi-squared degrees freedom 1 equal to 3.841. So I just needed to include that extra bit there to say that that's how I'm comparing it, that I've compared it to the other critical value. And the reason we're doing that is because we don't have a p-value. Now, if you look in the comments of this slide, you can see the same exact write-up, but using the SPSS output, but I had to cheat a little bit and use the chi-squared value that Excel gave us in order to do that write-up. So there is no perfect solution here. Since we found significance, that means that our null hypothesis, that there is no statistically significant difference between the observed frequencies of KC and HOT questions before and after an intervention, was rejected. Your assignment this week, I hope, is relatively straightforward. You're basically going to do a similar, the exact same scenario we just did, but with different data. So we're going to test whether there's difference in the frequency of HOTS questions and comments using pre and post observation data in this table right here. So you're just going to perform a McNemar test to address this scenario. You can use either the Excel or the SPSS output. I did not give you either of those with this data already entered. So you'll have to manually create both of those or modify the template if you're using Excel. Be sure to include a screenshot of your Excel output if you use Excel, or the output from SPSS. I hope that you felt this last lesson was not super crazy difficult, and that this last assignment here will also not be too crazy difficult. I hope you are doing well. Please feel free to reach out if you need anything from me.